Hello everyone, this is Sudipta Chakri from Bangladesh University of Business and Technology BUBT, Dhaka, Bangladesh. Today I'm going to present our paper on behalf of our research team, that is illegal trash thrower detection based on HOGSVM for a real-time monitoring system. So first of all, I want to congratulate the organizing committee of the Second International Conference on Robotics, Electrical and Signal Processing Techniques Committee 2021 for arranging such an virtual environment for this conference, even in this pandemic situation. Now, we want to segment our whole session into seven segments that we have shown here to the goal to the reference part. Then we will discuss this whole systems or whole of our system in our later slides. The primary motivation that has thrived us to do this work or do this research is that we have observed or sometimes see that in urban areas, almost all of our houses are equipped with CCTV cameras. And the people live in that houses sometimes legally or illegally throws the litter or trash outside their home and thus pollute the environment. To reduce the rate of this pollution, we have proposed a real-time monitoring based algorithm that will effectively detect the trash and the illegal trash thrower at the same time. So this is the literature review that we have counted in our reference part. In one, the authors proposed a method to detect illegal trash littering person from an environment, but that is not enough to detect trash in a robust environment. That is their lackings because no background subtraction procedure was done there. In two, the authors proposed a sterile monitoring zone management, but no shadow removal process was done. That is why their performance was not that satisfactory. An intelligent surveillance-based system is used to detect smoke and flame for the precautionary purposes from the surveillance-based environment in 5. In 6, the authors proposed a method to detect humans from static images based on the histogram of oriented gradients Hawk feature descriptor. Besides, contrast normalization is used to enhance the performance of the graph. In 7, the author proposed a cascade-based feature extraction for the contour and texture information effectively for starlight zone monitoring management, but the system fails to detect multiple humans from the occlusion environment. Authors in A proposed an improved version of the human upper body detection procedure based on the extraction of the shape features and SVM classification model, but the detection of the human body part was partial and they failed to detect multiple objects at the same time. A feature-based object detection framework is proposed by Amir Sulaiman and others in A9, which was assisted an intelligent surveillance-based system. To detect dump trash from the water surface, a neural network-based work is accomplished to save the environment from the pollution in Till. So we have shown our overall methodology of our proposed system here as a graphical figure. First of all, we need to feed our initial video frame to the shadow removal stage. This stage will enhance the performance of our works than the previous works that have already done. As we have done shadow removal process before background subtraction, we have observed that our performance for this detection and classification problem was slightly higher than the previous proposed theorem or algorithms. The binary frame that will be the output from the background subtraction part will fed to the morphological operation part. As we all know, morphological operation is used to reduce the noise levels. So in that case, or in this purpose, we have also used that morphological operations like closing or opening operations. We have performed some leveling and filtering operations for effectively identifying the region of interest parts. And to detect the trash, if it's a trash or not, if it's a trash, then we need to collect the hawk feature extraction parts. And if it's not a trash, then we need to we need to go back to our previous stage, shadow removal stage, and effectively done. Then successive stage. That means background subtraction, morphological operation, leveling, and filtering operations again. If we can successfully organize or detect this object as a trash, then we will extract the features for the human or non-human parts for the classification problem. Hog is a good classifier for extracting the features for human, and we have used this hog feature extractor for the classification part that we have used support vector machine classifier as in our project. So support vector machine classifier will effectively identify human or non-human from that video frame. So our works is separated into two parts. The first part is trash detection. The second part is person detection. So for the trash detection part, we need to have background modeling. Background modeling is very, very necessary for identifying the foreground information, because initial frame does not consist of any foreground information. For that background modeling part, we have considered this probability density function and probability function for which is denoted as P of xt in the mathematical format. Then we have performed some foreground detection part for the moving objects from the video frame. So we have compared our current pixel with the previous background pixel, and using this standard deviation, and we have set up threshold level t equals to 2.5, and if we see that the threshold level goes higher than 2.5, we have considered that as a foreground part. Then the rest of the parts are considered as background. Then we need to update the background as shown in this slide using these mathematical equations. Here alpha and beta are two learning weights, where alpha is the constant and beta is our secondary or auxiliary learning weight. For morphological operations, we have used opening and closing operations, and using this operation, we have significantly reduced the noise levels. For the leveling and filtering part, we have used 4 connected and 8 connected regions to effectively level and filter those operations and effectively counted as region of interest. Then we have applied Hawk feature extraction algorithm, and it has 5 steps. The first is gradient computation. As you can see, the S of x and S of y are our 2 different gradients for the x and y axes, and using these values, we have calculated the value or the magnitude value m and the orientation value theta. Then we have performed some orientation binning. We have considered 9 bins. Each bin consists of 20 degrees. That means total 9 bins consists will be 180 degrees, and using the gradient information of x-axis and y-axis, magnitude and orientations are calculated. And then we have calculated the histogram of gradients for the each cell in our later part. Then we have normalized the blocks to improve the performance for the extraction part. Then we have applied feature vector calculation. Here we have 7 blocks in the across part, 15 blocks in vertically, 4 cells per each block, and 9 bins per histogram. Total 3,780 values. These values will be fed to our recognition stage. For person recognition stage, we have used SVM as our classifier. SVM classifier is a binary classifier which looks for an optimal hyperplane as a decision function. And if it's trained with some sample containing human and non-human parts, SVM can effectively identify human or non-human from the testing video frames. Here is some experimental results, as you can see. In our figure A, this is just a initial frame. In our B, it has a trash part or foreground part in this picture, And in C, we have detected the foreground part, that is the trash part. And using the superimposed technique of the video frame and the binary image, we have effectively detected the region of interest part. Then in our experimental results in this figure, we have effectively identified the human using the binary classification SVM classifier, and we have already identified that trash part using previous experimental results from the previous experimental results. So if SVM outputs as positive, that means if it's a human. If SVM outputs as negative, that means if it was not a human. So here is the performance analysis of our project. We have considered two situations, simple background and complex background, and we have counted some frames, 505 and 509 frames for each situations, and we have counted the recall and precision values for those situations, as you can see. In our table 2, we have shown a quantitative analysis for our proposed framework, and we have got the recall, precision, and F measure values for the previous true positive, false positive, and false negative parts. In this computational type competition, we have considered our frame 1 as a lower resolution frame. Frame 2 was a higher resolution frame, and frame 3 was a moderate resolution frame. So you can see using the three different resolution, we have calculated for 5 or 6 basic levels: foreground detection, morphological operation to SVM classification stage. And basically the average time was 3.92 seconds for the computational part. And we have compared our works with with a proposed work in 8, and we have effectively outperformed our performance to a higher extent. So here is our conclusion part. We have proposed a framework that is based on background subtraction and HOG feature descriptor based one. HOG feature based descriptor effectively detect human and smooth the image at a higher extent. That is why we have used HOG as our feature descriptor. Then we have applied shadow removal processings. Because using this shadow removal processing, we have enhanced or improved our performance. We have used SVM as our classification classifier. SVM is a optimal classifier, and its maximum margin hyperplane is one of the best to reduce prediction errors. So we have used SVM as our classifier. As our data set is comparatively a smaller one, in the future we'll enrich our data set and improve the performance using some artificial neural network based advanced classification problem. Here is the reference part of our works, and thank you all for watching this video today. And if you have any questions, feel free to ask. Thanks again for organizing such a beautiful conference. Thank you.